Hi, everybody. Welcome to the February 2024 Secure Stage Roadmap Review. I'm Sarah Waldner, Group Manager for the Secure Stage and also Product Manager for the Vulnerability Research Team. I'm joined here today by Connor Gilbert, Principal Product Manager for the Static Analysis Team, Sarah Medsinger, Senior Product Manager for the Dynamic Analysis Team, and John Crowley, Senior Product Manager for the Composition Analysis Team. We're going to be walking you through some highlights from the last few months that we've recently released, and then we're going to dive into what we can be looking forward to for our roadmap. So kicking off, in 16.8, we released the first iteration of pre-receive secret scanning. This is available as an experiment today, just for dedicated customers, but more on what we can look forward to coming later. So pre-receive secret scanning is the ability to block secrets during the push. So as a developer is writing code and then goes to push to the remote, it scans those changes, identifies secrets, and then blocks that push before they are ever published. This is an excellent tool for covering well-identified secrets that can be found at a low positive rate and complements our existing post-receive scanning secret. We also have from the static analysis team work to be done on updating and enhancing our SAST rules for fewer false positives and improving and expanding our automatic cleanup functionality. So our rules here define what vulnerabilities GitLab SAST can find. We manage these rules for the subgroup-based analyzers, and these rules, as a reminder, cover many popular languages. So as part of this release, we've removed dozens of low-value rules to improve our false positive rate. Built and released automatic vulnerability resolution to automatically clean up customer projects when we remove rules, and updated the logic for more than 40 rules. We also released a new view for how you can view SAST findings in the merge request diff view. This is available now. So it's easier than ever to understand and fix vulnerabilities when they're shown in context to your code. We now show these SAST findings right in the MR Changes tab, also known as the diff view. This helps developers and security pros understand the vulns we found and fix them during code review. Coming up next from our composition analysis group, improved stability for operational containing scanning is available now in GA for our ultimate tier. In 16.9, we made improvements to our operational container scanning tool. Users will experience a more stable experience due to the team removing the need to parse Trivy logs. This often caused scan failures and created a confusing experience for users. Additionally, we increased the report size from 10 megabytes to 100 megabytes, which will enable more users to leverage operational container scanning. Moving on from the dynamic analysis team, we released new DAST authentication options and active rules. This is available now in Ultimate. We've added the DAST after login actions variable, which enables you to provide a list of actions to be executed after the crawler logs in your web app. This allows for multi-step login interactions, for example, Azure AD's Keep Me Signed In workflow. Browser-based DAST can now more fully cover applications using these multi-step auth flows. We've also added 10 new active check rules for browser-based DAST. These rules help identify high-severity vulnerabilities, including, but not excluding to, server-side request forgery, server-side code injection, remote file inclusion, and SQL injection. Okay, we're going to be moving on to the roadmap part of the presentation. Here is my obligatory message. Presentation link pages contain information related to upcoming products, features, and functionality. It's important to note that the information presented here is for informational purposes only. Please do not rely on this for purchasing or planning purposes. Okay, this is a little sneak peek at the Secure Stage 12-month roadmap view. I'm not going to go through all of these items in detail, as this can and does change throughout the year, but these show highlights that we can expect to see Q1 through Q4. Okay, I'm now going to hand it off to Connor to walk us through what we can expect from the static analysis group in the next quarter.
Sure, thanks, Sarah. So within static analysis, we cover secret detection, SAST, IAC scanning, and code quality. I'll cover some of the highlights for those areas today. So starting up with something that we discussed just a moment ago, pre-received secret scanning. So that's, as Sarah mentioned, a way to stop the secrets from finishing the push process. You can see in the screenshot, it's a developer's typical git push operation, and the server's actually responded saying, there's actually a secret here that you can't push it. The production version of this message is slightly different, but that's the flow, and that's what you see in on the image on the slide. So Sarah mentioned we've released this in experiment undedicated. That's for particular reasons that we can discuss if necessary. But our next target is a really exciting one. It's getting to beta on GitLab.com. That in the meantime, that's sort of the target. And what we'll be doing in the meantime is tuning how findings can be bypassed. It's very important that you allow for deployments and other types of automatic actions to happen in the case of a false positive result or like a test value or something like that. Analyzing and improving the UX in various commit scenarios. There's actually a lot of places where you can commit code to GitLab, the single file editor, the web IDE, the pipeline editor, all types of different places that we want to make sure that we've integrated this feature in a way that is clear to users. We also have a lot of testing going on. So a lot of like high load performance testing, basically stress testing the system to make sure that it's set up to handle the load that we expect. And also that it's a good foundation for the future. So as we move on to sort of post-receive scanning and reworking how that works, want to make sure it's a good technical architecture. Customers who are interested or account teams that have customers who are interested, especially if there's any interest in pre-general availability testing, can comment on an issue. It's linked in the slides, and then you see the number there if you need to look it up. Next, we can move on to more of the SAST area. So I'm talking about the ultimate SAST experience with rules and engine. So when we think about how customers actually experience SAST, how developers are getting results, the quality of those results really are driven by the scanning engine, which is how we understand and model the code that they've written, and the rules for the detection engine, which is sort of the specific vulnerabilities we're looking for in that model that we built up. And in this area, we're looking to invest in both. So there's more rule logic updates coming up, building on top of the ones that Sarah covered earlier, and continued investment in a next generation scanning engine that provides the cross-file, cross-function analysis, better tracing through the program to be able to find the security results that provide the most value add over what a human could find. To be able to really trace through the program and understand all the different pieces that come together to create a potential vulnerability. That's a long-running project on our side and something that we're excited to be progressing toward customer availability. And then finally, one sort of specific version of this type of thing on the engine front is the SAST analyzer consolidation. So this is a thing that many folks will probably be familiar with if they've been engaging with GitLab SAST over the past 2 years or so. And what we're doing here is reducing the number of language-specific analyzers in SAST. So when we started off, we had analyzers that were sort of that were decided to be the good analyzers for each language. Usually they're written in that language and they provide that type of detailed scanning. And over time, we've been consolidating them, replacing them with GitLab maintained rules for detection in a semgrep-based analyzer that we also produce and maintain. And the reason to do that is because you only need source code, the scans run faster, we have the opportunity to provide better detection rules, make it easier for users to customize that behavior and the rules used, and to consolidate the number of jobs running. So today, if you have a sort of polyglot project with lots of languages, you end up with a lot of jobs. So in previous years, we've removed 4 analyzers and removed Java coverage from the spot bugs-based analyzer. And by 17.0, we're planning to remove 5 more of those, and also remove 2 more languages from spot bugs, which is one of the analyzers that can be the most difficult to maintain. For issue details, you can see that issue that's noted in the slide. So those are some of the biggest things we're doing in static analysis. Of course, there'll be more things that are happening and other improvements to the other parts of the system, but those are the big headlines. And with that, I'll pass it back to Sarah.
Trying to find my unmute button. I apologize. John, over to you for composition.
Sure. Thanks, Sarah. So I guess first up, let's talk a little bit about continuous vulnerability scanning. This functionality allows users to get faster insights into the risk profile of their projects. Instead of needing to rerun your pipeline jobs, this feature is going to add a vulnerability to your vulnerability report automatically. So essentially, anytime there's a new vulnerability advisory added to the GitLab advisory database, your scan results are going to be updated, and you'll see that data in the UI. This is currently GA for dependency scanning. Currently, we're working through support for container scanning, and then we're going to turn our attention to our container registry scanning as well. If you want to go to the next slide there. Thanks, Sarah. So the next up, we'll be focusing on broadening our scanner coverage. So there are two efforts that we'll be focused on in the near term. So number one is adding support for Android, while also improving our existing Java and Python support. Longer term, we're going to be focused on Swift and Rust. Language support is an important part of SCA scanning. By supporting more languages, we're going to allow users to get better insights into the health of their application, spotting more vulnerabilities and painting a better picture of what is exactly in their application, so they can make effective remediation decisions and understand just what makes up their open source within their larger application. Throw it back to you, Sarah. Thanks.
Thank you so much, John. That's very exciting. I'm going to hand it off to Sarah to go over dynamic analysis.
Thanks, Sarah. We're currently working on some DAST and performance improvements. So we're adding more intelligence to how we crawl websites in order to speed up our browser-based DAST scans. We know that the speed of DAST scans is a common complaint for users everywhere, regardless of what DAST solution you're using. It can take just much longer than other security analyzers do. And our browser-based DAST offering does a more extensive job of crawling websites than legacy proxy-based approaches. So we can crawl modern web apps more deeply than legacy solutions do. And there's a bit of a trade-off with the number of vulnerabilities we identify, how deep we're scanning a website, and the performance. But we do know that speed is critical for any DevSecOps process, so we want to optimize it as much as possible. And then we're also working on an API discovery beta for our DAST API and API fuzzing offerings. So we're automatically generating open API documents so that you can more easily test your APIs for vulnerabilities. It's important because we've heard a number of customers tell us that not all of their APIs are documented, and not all of their APIs have open API specs, but we need those specs. They're standard schema documents that help us understand the expected behavior of the API. So we use those specs to help us recognize whether we can take unexpected actions, which would indicate security weaknesses that you would want to remediate. So currently Java Spring Boot v2 is supported. We're adding support for Python Flask and Django, and then we'll add additional framework support after that.
Thank you so much, Sarah. Now this presentation is going to be available ahead of the AMA that we have next week. So please come join us for a live Q&A.